All right, good evening, everybody. We're going to get started here. My name's Jonathan Beater. I'm the Director of Public Works. Tonight we're here to talk about the Forges Field well. I'm glad everybody showed up. Thanks for coming. We have a decent little crowd here, nice and informal tonight, okay, which is good. We kind of like it that way, kind of low-key. We'll just kind of talk directly. Any questions, just save till the end, please, and just make sure you come up to use the microphone because we're going to be airing this on PAC TV throughout the week. We'll be able to YouTube it. We'll put it on the town's webpage so anybody can see the information after the fact. Tonight, beside myself, we have Pete Gordon and Sheila Scazi from the town. We also have Rich Tierney, our water superintendent, and they have Anne Marie Patrica and Ryan Trahan from Environmental Partners. We've been at this project for quite some time, several years now when we started the engineering, going through town meeting 2 times for engineering design and then the construction costs. And now we're kind of, I'd say we're about 75% with permitting with the DEP and MEPA, and we're probably about 90% complete on our design drawings. The plans are in the back. If you want to take a look at them, feel free. We'll give you some time at the end to do that. There's a sign-in sheet as well for your name and contact information, especially your email address. If you have questions we cannot answer tonight, we'll get those answers to you. Audience tonight, we've sent out about 150 letters to all the abutters. We did a series of press releases. We put this on the town's webpage, social media, just to get the word out, to get people here to ask questions. I like meetings like this. This is good where people can really interact with the town and our consultants to really understand how we got to where we are today and what we're trying to do and why. Your water system has about 40,000 customers. We have about 14,000 connections. We have about 200 miles of water main, 6 pressure zones, and 11 wells. So it's a fairly large and complex system. We have a lack of redundancy. I don't know if anybody has been paying attention to what's been happening over the past couple of years, but what's happened is we had a drought in 2016, which really exposed a lot of deficiencies in the system. We have a lot of development in Plymouth Center and West Plymouth, and a lot of the water is used there. Your average water is about 4.3 million gallons a day, but what happens in the summertime, that really jumps up to about 6, 7, even 8 million gallons a day. So what happens is we have a tremendous need in those built-out areas, so we have to get water there, and we don't have it. So what happens is, you know, Rich, Pete, Sheila, they have to constantly fill the tanks to make sure that we have enough water. And our concern is if there's a fire, we need to make sure we can provide proper fire protection. So 2016 established a lot. We really started working very closely, you know, with environmental partners, our Board of Selectmen, to really establish what we need to do to address those redundancy issues and make sure we can meet peak demand. Therefore, we've come to Forges Field well. So what we want to do today is I'm going to provide you a real brief snapshot of what we're doing and why, and then Anne Marie and Ryan will kind of go through some of the more details in terms of the modeling, the well itself, impacts, and then what we can expect for construction. And then we'll answer any questions, and then we'll just take it from there, okay? So thank you. So just a real quick snapshot. I think it's beneficial to see a picture and understand what we're doing before we go into the details. What we're looking to do is construct a well here. This is the Forges Field well off of the access road. And then this is a new water main to a valve control station. And what happens is the well is here, and this is a pump station, so the water will pump up. This station here will be able to control how we feed water into the 2 pressure zones, which is Plymouth Center and Bradford. We'll run out up Jordan Road to Russell Mills Road. Under the culvert here, we'll do a directional drill underneath that culvert, and then we'll run up and tie into the existing Bradford pressure system behind the wastewater treatment plant. And all the residents here on Russell Mills Road will be able to tie into that new water main because we are aware we do have pressure issues. But that's it in a nutshell. It will be bid in 3 different projects. There'll be a water main bid, a new pump station bid, and a valve control station bid. We're going to talk about why we need new water supplies this evening. We'll give you a little bit more background and what we've been doing and why. We'll talk about the Forges Field well site, the pump test results, the effects or the impacts, if any, on nearby wells, what we've done to model the Yale River watershed group, and then what our future schedule is, and then we'll take questions, as I mentioned a minute ago. Why do we need a new water supply? We need to allow for future economic development and the expansion of the water system as we have it today. We need to provide that emergency redundancy within our system and allow for flexibility of withdrawals and distribution. What we mean by that is as that peak demand increases in the summertime, we have to make sure we can feed that. We have about a 1 million gallon lack of water during those peak demand periods. And then we need to make sure we can plan for long-term sustainability. And that's what this well will do. At least this well will start us down that road. This all dates back to our 2006 master plan. That's the last time that the town did a master plan. This past spring town meeting, they allocated funding or appropriated funding for us to start a master plan, which we are starting in a couple of months to really update that. That master plan pointed out additional water supplies are needed, and we have redundancy issues at our current wells. We have pressure zone deficiencies, especially with Bradford, Cedarville, and Manomet. Some of the wells that 2006 master plan looked at had conservation restrictions on, so we need to make sure we were aware of that. And then there is a water storage deficit in terms of how much water we can pump into the tanks and store, during those peak demand periods. So again, that master plan that was done back in 2006 identified 21 viable supply sites. Between 2008 and 2010, Horsley and Witten was the consultant the town used to do some exploration at 5 of those sites. Several months ago, the town really was looking at Forges Field and 200-acre sites, both those two. We did a lot of discussion, a lot of investigation, a lot of analysis, and we selected Forges Field as the site we went to town meeting for in the spring. Some of the benefits of Forges Field are reduced reliance on our stressed other sources, our other wells. Additional water to meet summer demands, which is really critical here. And then the redundancy for the Plymouth Center and Bradford zones. And ultimately, a lot of improved pressure services along Jordan Road and Russell Mills Road. And most of you are direct abutters, you understand that we have low pressure and some of those hydrants aren't even in service. So our preliminary estimate for the well is about 1 MGD, and that's what we're permitting it for. The exploration started back in 2016. We ran pump tests back in 2017, and we've done modeling since 2017 up until several months ago. And Forges Field well will provide immediate benefits to the town's water system. So with that, I'm going to turn it over to Anne Marie from Environmental Partners. Thank you.
So I'm a hydrogeologist, and I was involved in a lot of the permitting of the water supply well, the testing, the exploration, and without getting into too much of the geology, I'm going to give you a big picture on, what we did out there, what the well can produce, how we know it, a little on the geology, and then go into the modeling results, because we spent a lot of time trying to evaluate how this well will affect the surrounding area. So again, this is the Forges Field site. This is where, in 2016, we put in 7 observation wells and 1 test well. We did exploration. All these wells go down to 130 feet below ground surface, which is where we hit bedrock. And the best aquifer material for water supply is down deep. So the wells are all screened from about 125 feet to about 110 feet below ground surface. So it's a very deep well. The water table there is at 27 feet below ground surface, so we have a lot of water to work with there. And so before we started the pump test, we put in water level loggers in all these wells, and they go out about 900 feet from the pumping well. And we monitored water levels hourly for a week before we started pumping the well, so we had background data on what the water levels are doing. Then we turned on the pumping well and pumped that at about 750,000 gallons a day. Pumped the water well away so it's not coming back, and monitored the water levels in all of these wells. So we could get a good idea what the drawdown of the water table is at the well and as we get further away from the well. And that's what all went into the model, and so we could calibrate really nicely and close in at the well field and then use the existing model later, and I'll show you the model. At the end of 5 days, we tested the water. using all the required testing that DEP has, and water quality is excellent. It was just pH adjustment, which is typical in the southeast Massachusetts. And the approvable yield using DEP's method was 1.048 million gallons a day. So it's about 728 gallons per minute. So that's what we put in the pump test report to permit the well. So once we had all that data, worked it up, the USGS back in 2009 did a water supply model for Plymouth, Carver, Kingston, and Duxbury. They included all the production wells, any irrigation wells that they had, and the purpose of the model was to evaluate groundwater supply well impacts to the aquifer. So it was a tool for towns to use to evaluate any impacts from water supplies. And so this is the whole model area. Here is where's the Forges Field well is right there. What we did is we took our water level data and put it into this huge USGS model, calibrated the water levels to what our water levels to the model, so calibrated beautifully. And so once we knew that, we could pump the well and see how the water table reacts, and we can see where the well would get its water from. So with the model, let's see. And another thing, all the wells in Plymouth were pumping at the time we did our modeling. So we had the Bradford wells, the Lout Pond well, the South Pond wells, and all the irrigation wells that are in this area that pump very hard in the summer. They pump for 210 days a year, and then they don't pump in the winter. So we had all those pumping too. So we had everything going on, and we used the data for the last 5 years in terms of how these wells were pumping. So then in our pump test report, DEP requires us, first of all, to figure out what our zone 2 is, and this is the area that there are use restrictions. And the zone 2 is defined, we pump the well in the model at the permitted pumping rate, which is 1 million gallons a day, and we have no recharge to the aquifer, so we're looking at severe drought restrictions. And then we use the model to tell us where is that well going to get its water from. And that's what this area is here. It goes out to Gunner's Exchange Pond. And here's the Forges Field well. These are the golf courses in here. And it's residential. So the Zone 2 land uses are all consistent with what a Zone 2 DEP requirements are for land uses. So that would be drought conditions that, rarely happen. Then we wanted to look at if we pump the well at 1 million gallons a day for 100 years, how far out would we see drawdown to the water table? And that's what the area of influence is, and that's another thing DEP requires you to submit in your pump test report. So this line here represents the area of influence, and that is calculated by the 0.1 feet of drawdown with the well pumping 1 million gallons a day for 100 years. And so this is the area of influence. You can see it runs here by Russell Mill Pond and down here towards Pine Hills, and it goes inside of the Little Island Pond, I think is what this one is, and then it goes out to Gunner's Exchange Pond. So that's the area of influence that it would have. And again, we have all the wells in town pumping at the same time. Yeah.
So is it 0.1 feet at the border?
At the border, yes.
So inside of that, it could be more.
Yes, you'll see, and I'll show you next slide is a good question, because there's the drawdown inside and close into the Forges Field well. So here's the Forges Field well. Outside we have 0.5 feet of drawdown, a 1 foot, 1.5, and then these are all 1 foot of drawdown. So what we did is we wanted to see, okay, what is nearby that is in this area of drawdown. And again, this again is 100 years of pumping. So this is equilibrium, and it takes about 5 to 10 years before you actually reach this. So this is what's called steady state. And we had, like I said, the irrigation wells pumping and all of the town wells pumping in the model. So what we wanted to look at what the pumping effects are for the neighboring wells, knowing that everybody is on a private well in this area. So here's the Forges Field well. And on this map, I took those drawdown curves that you saw on the last map and color-coded them. So this one, the red is 5 feet of drawdown, this is 4 feet of drawdown, 3 feet, 2 feet, and then that's 1 foot of drawdown. And again, this is a worst-case scenario. It's pumping 100 years. And when we put in the production well, this was a test well, and the production well will be an 18-inch well. It has a better specific capacity, so we don't expect as much drawdown in the final production well. This was based on our test well.
Can you orient us on that map?
Okay, yeah, I can do that. That's a good question. So here's Forges Field Road coming out here. This is Jordan Road running down here, and it intersects with Long Pond Road down here. And obviously there's Route 3.
Are those houses, now we have Jordan Road, the purple, and those are homes, the white outlines?
Yes, those are.
And so where is Rollingwood Lane on there?
That would be right in here, and we have a lot of well data from Rollingwood Lane. So what we did, we went to the Board of Health, and we went on DEP's website and tried to get logs for all the private wells we could. There's not a lot of private well data, but all the private wells that we could get data for are here in green. So all of these lots we had, some of them we just had the depth to water, and we had where the screen was, which is what we really need to know. How much water do you have above your well screen if we turn on this well? Some of them did have some geology, and so now what I want to do is look at, I'm doing a cross-section right along Long Pond Road and up Jordan Road, and I took our production well and just projected it into that line so you could see how our well drawdown compares to what we're seeing out here. And so there's a lot of information on this cross-section, but so this starts down here at Long Pond Road, and it's color-coded here. So the purple's Long Pond Road, then we hit Jordan Road, if you look at that cross-section. Then we projected in our test well, and then this is the Rollingwood Lane. All these wells were Rollingwood Lane. And a few Jordan Road wells are projected in.
Question.
Yes.
I live at 57 Jordan Road, 53 Jordan Road.
You don't live with us.
Yeah. But my question is, are you saying we're going to have a 4-foot drop in our water level? Like that's like
5 to 10 years?
In about 10 years. So that's, so, yeah.
well, I mean, there's going to be a drawdown.
There will be some drawdown, and that's what I want to explain what I have on here. So, and I do show the drawdown at 35, 57, 66 Jordan Road. So the cross-section, wherever there's yellow, it shows what the geology is, and the green. If it's white in here, all I had was the water level and the screen interval. And then, so we have no data on the geology, but you can tell here it's all sand and gravel. It's an excellent aquifer. We know that. Plymouth is underlain by a big sandbox. These are the well screens down here. And our production well is right here. You can see we hit bedrock down here. And I believe there's some borings over there on Rollingwood Lane that actually hit bedrock too. So we know how much aquifer we have to work with. And so the blue line here shows what your water level is today. And that's based on all these logs. Then what we do is, and all the wells in town are pumping at this level. Then we turn on the Forges Field well. We draw it down here. We're pumping at 1 million gallons a day. And the red line shows what the drawdown would be in all the wells we have logs for. So you can see it's largest, closest in. We have about 4 feet of the wells closest in, and as we move out, it's essentially on top of each other, so, a foot or less. And, you know, some have a lot, some have less water, but the way we look at it is your private well pumps at about 5 or 10 gallons a minute. It's a 4-inch well, so that's about what you can do. And the formation out here is excellent it's an excellent aquifer. So the formation can give up about 10 gallons a minute per foot of drawdown, and that's a low estimate on the geology. So if your well is pumping at 10 gallons a minute, and the formation can give up 10 gallons a minute for a foot of drawdown, if your well should be drawing down about a foot when you turn the pump on. Is kind of how it works. So as long as you have water above your well screens, it should not have an effect on, you know, your operating wells. And then as we get further out, there's like next to no effect.
The well screen that you show at 57, how far is that down below what's the base?
I think there's about 12 to 15 feet of water above the well screen. The logs we had, I took a look through, some had 12, some had 15. And then if we draw it down, you know, 3 feet, then we're looking at, instead of 15, you've got 12 feet of water. And your pump turns on, it'll drop it a foot. If your pump is only pumping at 5 gallons a minute, you may only go down a half a foot to a foot.
I know we're supposed to ask questions at the end, but
Everyone else is, so.
so I'm at 81, Jordan. So you're telling me that there's 12 feet, but in 5 to 10 years, the water level's gonna go down 5 to 10 gallons?
So you're at 81?
I'm on the other side of the green.
Okay. Oh, right there. Okay. So, yeah. So you have a lot of water above your well screen. If I can look over here. So 81. You've got close to 20 feet of water above your well screen. Yeah.
But 5 to 10 years it'll be capped.
No, no, no. So 5 to 10 years from now, you're going to drop it down about 2 or 3 feet. So you can see, like, scale this out. Here's your water level before. We're going to draw it down to there, and you still have that much water left. So those wells were drilled nice and deep. They're all good wells.
So if we're reading right then, 57,
57, yep.
we live, by the way.
Okay.
So we lose half our available water.
You lose, you're probably in the 4-foot range, I think, and you still have about 5 feet above it, so. Yeah, and again, this is worst case scenario because we believe the production well is not going to have as severe a drawdown. The production well should have better specific capacity, and what happens with that, in that case, you have more gentle drawdown over a larger area. So, as long as your pump comes on and you're going to pump it down a foot or two, and you still have like 4 feet above your well screen. So now I'm going to turn it over to Ryan. He's going to talk. Sure.
Based on the last diagram. Again, we're going back to the 57 Jordan Road.
Yep.
That, what you have here is estimates, again. Is there going to be, now you did test wells to test the water levels. Are you going to do any monitoring in there? That seems to be the area with the most crucial need for continued monitoring in terms of your water levels. And those are an area with houses that have septic systems too, which is another problem. It's not just a question because you've got the surface water and septic systems working down too, the more you draw that water down. So that's a crucial area, and I just don't know, are you planning to do any continued monitoring in that crucial area?
Yeah, great question. Yes, we will be putting a monitoring well in that area. There's a piece of town property, so we can monitor what that drawdown is over time.
Yeah, and it'll be upgrading, so we'll see changes before you will.
And just to, again, my name is Ryan Train with Environmental Partners. My area of expertise is mostly design of well supply, water infrastructure, permitting, construction management. So I'm going to touch base on more on the overall arch of the whole project, give you a little education on how the water system works in this area, and then what you can anticipate during construction and what time of the schedule. And just to reiterate a little bit of what Anne Marie was saying, that the model that we have was pumping all the existing wells that the town has at their full permitted capacity, which due to age of the wells and lost water quality, the town does not currently pump all they can out of those wells at that time. So the model is a very conservative approach. So we do that, and DEP requires that, and that's part of the permits that we submit. So just wanted to make sure that's clear. And we're not, this amendment to add this well to the town, we're not asking for additional volume of water to withdraw from the overall aquifer. This is to add a redundant source. So we're not going to be all of a sudden pumping 1 million gallons more into the water system. This is just to help out balance the entire water system and to reduce the impact on some of the well supplies that are stressed right now and that have poorer water quality.
So if the Bradford wells are not, if the Bradford wells are not pumping as hard as they are now, the water table will rebound some, and then our pumping would be less effect.
Okay. So as JB mentioned, first, the most important part is construction of the well station that will actually be able to pump the water out of the ground from the well. We'll be adjusting the water, the pH of the water to neutral, and we use a chemical for that. There'll be approximately about 3.5 miles of water main to tie in this well station along Forgersfield Road to the distribution system. And as we mentioned before, we're lucky with this supply because it's almost right near the boundary of the Bradford pressure zone, which ends here, and the Plymouth Center pressure zone. So we took this opportunity to not only add this supply to the water system, but we looked at an approach that was cost-effective to actually help an existing pressure deficiency and fire flow deficiency on Russell Mills Road and at the end of the Plymouth Center system. So by adding this supply to the town, by tying it into the Plymouth Center and the Bradford zone, it increases the ability for the water division to move water to the West Plymouth area of town, which is the area that's in most need of water. This valve control station is essentially going to be the new boundary of the pressure zone. So water is pumped out of the ground. It flows through one pipe on this side, on the west side of the road, northwest, will pump up Russell Mills Road and go into the Bradford zone. This valve station will reduce the pressure down to the Plymouth Center zone, and it'll go through another pipe on this east and southeast side of the street, and then that'll tie in and continue up Jordan Road.
I have a question. I didn't hear, would you please tell me again what part of town needs more water? What did you say?
The West Plymouth area.
West Plymouth,
Correct.
like where? I mean, Charlotte Drive or all the way up to Carver or Route 80 or?
Colony Place area, yep.
So you're talking about the commercial section of town?
Commercial section, residential. The whole zone is deficient for water supply right now.
Residential and commercial?
Correct, yep. The overall demand of that zone.
This is going to help both?
Yes,
Thank
yep. The water mains, so we'll have, as I mentioned before, parallel water mains along Jordan Road. There'll be one water main on one side of the street and one on the other side of the street, and this will separate and be two different pressure zones. Part of the project is to replace an undersized and old unlined cast iron pipe on this road, on Russell Mills Road. And as of right now, the design is pretty much final, and we're just going through a couple of the last permitting hurdles before we go out for bidding. If you can imagine, a project of this magnitude requires multiple steps to go through for permitting. And there's not only the local Plymouth Conservation Commission has, I saw many of you at that meeting. We went there and received the approval. But we also went through multiple permits with the state. So I just want to go through those a little bit with you. As Anne Marie mentioned, a lot of the data that we collected and she spoke about tonight was included in that pump test report that DEP has to look at. So DEP has their own hydrogeologists. They go through and double check all the modeling efforts that we've gone through, all the water quality data, make sure that we're doing our job correctly. And there's a whole entire permit and report format that we have to follow and submit. That was submitted, and we actually received that approval last week. Because of the magnitude of adding a source to a water system and by expanding the water system in this magnitude, we had to submit an expanded environmental notification form with the state. That was submitted earlier this year, and I believe sometime in March or April, we received this certificate with no further action required. That process, essentially what it does is it notifies every single state agency for comment on this environmental project. So it could be the Division of Marine and Fisheries, could be the Mass Historical Society, could, you know, all these different state departments get a chance to comment on major projects like this. And then with the local MassDEP in the Southeast region, we had to submit an approval to construct the source, which those design plans that are up at the top there, along with all the project specifications, we have to submit that for their review and approval. That was, we actually got that approval this morning, so that was good news. There's another permit here that requires us, if we are creating or expanding a pressure zone or a valve station here, we have to submit what's called a WS32 permit. It's a simple form, and again, they have to review all the water mains and the valve control station building plans. They did that, and we actually received that approval this morning as well. Right now, we're right in the middle of doing the Water Management Act permit amendment, which, again, as I mentioned, we're simply just looking to add this well to the town's existing permit. We're not requesting any additional volume of water to be withdrawn from the aquifer, okay? So we're in the middle stages of this amendment process. We have to get back to the state on some of the comment letters that we received. Some of you might have written to the state, and part of, and that's why we're here tonight as well, just a public education process. We'll be submitting comments back to them, and we can anticipate a draft permit, new permit to be issued sometime in late August or early September. And then from there, we'll then get into a little bit of our schedule for construction. So as you know, in April 2017, the design and permitting and bidding was approved. And this past town meeting, construction money was approved for this project. And this is the tentative dates, depending upon the permitting cycle. We're looking at water main construction potentially over the winter, potentially next spring. But the bottom line is we're going to be looking at a very heavy construction season in 2019 and hope to have everything online in the winter of 2019 and winter to 2020. We anticipated doing a lot of public outreach during construction, similar to tonight. We're going to be putting the final contract documents on the town's website. We'll also have each of the homes along the project route will be flyered, which will be a notification will be stuffed in your door. Typically, we like to let you know at least 48 hours in advance of when construction will be going by your home and whether or not you'll be impacted by any of the work, so that you can take an alternate route to get to work or to the grocery store. We'll also be providing updates on the town website, and whenever we give you a construction flyer, we'll have all that information there for you on where to go to get more information. We'll have our email addresses on there, our phone numbers. You can give us a call if you have any questions. Some of you that may or may not be on town water, every property along the route will receive a new curb stop. A curb stop is essentially a valve that allows you to access water in the future. There's no, at this point in time, requirement to connect to the water system. However, it'll be left at your property line so that if you have the need to connect to town water, you'll be able to. And that'll be for all the routes that we showed you from Forgersfield Road, north along Jordan Road to Russell Mills Road, wherever we're doing the water main work. So I just want to go through a couple of quick photographs about what construction looks like, and you can stop me at any time if you have questions. This is generally, the water main trenches are about 4 feet in width. They go down and excavate about 5.5 feet to 6 feet down. This type of material is going to be very similar to what you're going to find here in Plymouth, mostly all sand. And the contractors move fairly quickly. You'll be surprised. You might go out to the morning, go to work, and by the time you get home, they might be 200-300 feet down the road. So they move very quickly. They tend to excavate the asphalt and grind that down. Then they start removing some of the dirt off the top of the trench, as you can see here. They excavate the soil out of the trench and then put the pipe in and then backfill and compact it as they go. And then at the end of each day, they sweep the road and with a gravel material bringing up the grade, and then every single Friday, that trench will be paved so that it's traffic is fine for the weekends. Okay. This is just what a typical valve looks like. So most of the pipe will be ductile iron. It's pretty much the standard of what's used nowadays for water mains. And this is a standard valve that would go to a fire hydrant or a larger commercial connection. This valve bonnet right here and this nut is what allows you to control the valve going up and down. So if you see some of the guys with these long rods going into the ground on the side of the road, that's them trying to turn and shut a valve or a valve off in the water system. How do we get water to your homes? Well, we have these corporation stops that are drilled or screwed into the water main, and then there's a piece of tubing that's connected to here, and that runs over to a valve that sits at your property line. That tubing connects to that, and then on the back side of the curb stop is where the homeowner connects to and then runs to their basement or crawl space, and where you connect to a water meter which tracks to your water usage and allows the town to bill you for the usage. This is what a curb stop would look like, a typical connection all the way from the water main is that corporation stop, all the tubing. Say this would be your property line, and it has a small, you might see a small iron lid at the top of your property in your grass or in the woods. That allows, again, to put a wrench down and be able to turn the water on and off so that in the future, when you want to connect to water, it's easily accessible and we don't have to go back and dig up the road again. Okay. And then that would typically go in a basement with some valving and connect to your water meter. Okay, so that was just hopefully a very quick, basic understanding of construction. You know, we won't be strangers. The best construction projects go smoothly when we have everyone's buy-in, not just the contractor and our clients, it's also the public. You know, we want to make sure everyone's understanding what's going on. And of course, there'll be police details out there along the roads to direct you around construction. And one of the questions I always get asked is, how can I access my driveway if there's a trench going by it? We typically always require the contractor to have steel plates on site. So those big steel plates can get easily put right across the trench, and you can drive right into your driveway. So just to wrap up, I think we've mentioned multiple times tonight, and hopefully we've hammered it home. But you know, this project is really to do all these items here. We need the additional water to help meet summer demands. Right now, we're doing our best to meet every demand that we have in the summer. As best we can with the supplies that we have currently. This will provide a lot of extra redundancy, another interconnection between the two pressure zones, which will allow us to bring water from the higher zone to the lower zone. And it'll also give some expanded fire protection along Jordan Road, Forgesfield Road, and also better fire protection on Russell Mills Road in this whole area. So, and this project in general will just help the whole water system be more sustainable. So, thank you.
Hey, just 1 second. Thank you, Ryan and Anne Marie. I thought that was very well done. Again, we'll take a bunch of questions. Everybody can ask whatever they'd like. We have a lot of experts in the room to answer those questions. As Ryan mentioned, you know, you can check the homepage, the town's homepage, for any information, updates, construction. In terms, I always get asked about schedules and impacts. Until we actually have a contractor on board, the well and the valve station won't really affect the residents at all. It'll be the water main. And once we have a contractor on board, we'll have a schedule from that contractor, and we'll publish that. You'll get another notification in the mail. We'll send some more information out to you as far as what the schedule looks like and what your potential impacts are. And again, you have all our contact information. You know, you can reach us and call us anytime. But again, with that, we're happy to take any questions, and thank you very much. Yes?
In your master plan for the Plymouth water system, April 2006.
Can I just ask any questions? If you could come up and use the microphone, that'd be fantastic. That way, because we're recording this, so PAC TV is going to air this, and plus we'll be able to send the video up.
My name is Jeanette Alzheimer. I'm a retired teacher in Plymouth, and together with my husband Frank, we built a house for our family 43 years ago on 53 Jordan Road in Plymouth. We have a shallow well, but nonetheless it has lasted us this time. Now, however, we're very concerned. In the master plan for the Plymouth water system, April 2006, there's a map of existing water zones on page 35. Granted, it's not been updated. But an examination of the location of those wells show that the houses in the neighborhood surrounding those wells have all been included in the plan to have town water. On page 37 of the environmental impact study speaks to the positive water supply being allowed Russell Mills Road and Jordan Road when the new well goes in. Yet the houses at the southwest end of Jordan Road, the ones closest to the well site, seem to have been completely ignored. They are not mentioned in the environmental impact study as far as a location. Has any consideration been given to using part of the contingency budget, which is considerably over $1 million, to extend the water main down the west end of Jordan Road to our houses not currently included in the plan, with curb stops at each house, so we well owners who are closest to the well site and having the largest drawdown will have an option, an alternative, should our wells be compromised?
So I'm gonna take some of that question. I think it's a very good question, and we have discussed it, but, you know, since that 2006 master plan, you know, we've done a lot more detail. You know, as Anne Marie and Ryan mentioned, you know, we did a 5-day prolonged pump test. You saw the chart in terms of the detail we have. That puts us in a position where we're comfortable, where we're confident that there's not gonna be a negative impact on your well. So there's been a lot of detail since that 2006 master plan to where we are today in terms of, you know, design, development, permitting, and we're almost ready for construction. You also saw information where we actually pumped that well at 1 million gallons a day for 100 years. We're pumping all the wells in the town at full permitted capacity, and you saw those results. So we're pretty comfortable with that. You know, in terms of running a water main up to Long Pond Road, we have looked at that. You know, if there is contingency money, I think that's something we can discuss further. But I will say there's a pressure limitation as you, if you back up the slides. I can speak to that if you want. You want it? No, it's probably this one.
The cross-section shows it, there you go.
That one?
Wanna take it?
Yeah.
So, everybody can hear me fine? I know it seems like maybe we could have gone down Jordan Road to Long Pond Road instead, and I want to let you know that that was certainly looked at. As far as cost, the route that we've chosen is actually 2,000 feet shorter. And at about $200 a foot, that adds up pretty quickly, okay? But the most important part of this is it's not always about money. It's about actually physically being able to do that with the hydraulics of the current water system as they are right now. And as JB mentioned, the pressures, because the elevation of the road along Jordan Road gets a little higher towards Long Pond Road, the elevation of the pressures in the Bradford zone can't fully support extending that zone all the way out to that area. And the pressure Plymouth Center zone that we're connected to is lower than Bradford zone, so that would even be more troublesome. So if we were to extend the main down to Long Pond Road, along Jordan Road, there wouldn't be sufficient fire flows to help protect your homes. And the pressures that you would receive would be very low and would hardly meet the minimum requirements set by the American Water Works Association of about 35 PSI. So you may each have a pressure tank in your basements. If you go look, some of them have pressure gauges on them. You can see most of the wells are typically set between 40 and 60 PSI on the gauge. So we're talking, if you can see in your house, the difference of going all the way down to the bottom is fairly significant. So it's not at least a goal of any of my designs or our designs, or hopefully the town, that we would try to provide something that would be inferior to what the standard service that you're currently getting.
Just going back to the maps, oh, sorry. go ahead.
Could you use the mic? No, please use the microphone.
Oh, yeah.
Thank you.
Okay. Just a question, what was the, when you did the measurements? Oh, here we go.
Go easy.
All right, and I'm looking at 53, 57, right in there. You have screens that are, what screen level are you determining because the wells in that area have different depths that they go to, the wells that provide water to the houses? Is that the minimum depth, or is that an estimated depth? Where you have the screens on the map there?
That is what the driller put on the drill logs that they filed with DEP and the Board of Health. So they gave you the top of the screen, the bottom of the screen, and the water table when they
Okay.
drilled the well.
All the houses?
All of those,
All the houses?
yes.
Okay. All right, that was the question I had. Thank you.
Yes.
I'm Rebecca Conroy, and I live at 21 Rollingwood Lane. And I was wondering, what will you have for curb access for water at 21 Rollingwood, the rest of Rollingwood Lane?
You probably can see from the plans there, we're just at this point going along Jordan Road, and at any road we go past, we'll be leaving a water main stub into the subdivision to serve them in the future.
So at that water main stub, would you put a fire hydrant there for our street?
The fire hydrants usually we like to put them at each intersection, and if you want to stay after, I can review the one that's potentially near Rollingwood, because the standard is to put them at every 500 feet for fire department purposes. And the plans are in draft right now, because actually the next step is to review everything with the fire department to make sure that they approve of all the locations that we've shown, so.
So if we have a negative impact on our wells, would we have to incur a betterment to get hooked up to town water if you have to run a main down Rollingwood Lane in the future?
Not necessarily. It all depends what the status of the town is then in terms of water expansion. Again, as we mentioned earlier in the presentation, this is a redundancy project in terms of meeting system needs. It's not a water system expansion project in terms of additional connections. But I do think if there were issues, related to your private wells, we'd have to address it at that time. And I think there's a number of abilities and options that we would have then.
And regarding the construction, it's during the winter. Would it be hours 9 to 5? But when's the starting time and ending time?
Yeah, generally we work, 7 to 4, 7 to 5, no weekends, but we do have flexibility with the contractors, trying to accelerate projects. The winter, we don't allow winter road work, but on this project, we'd probably do the cross-country stuff. Once you get past the end of Russell Mills Road going towards the sewer treatment plant, we probably allow work on the pump station, the valve control station during the winter, but actual work on Jordan Road, the paved section, there'd be no work during the winter months.
How large is the valve control station?
I believe it's about 12 by 18 feet. So it's a building with the double doors on it. It has like a brick veneer. You'd see it as you drive down Forgesville Road to the fields. Have a gable roof, and you walk in. Essentially, it's an open floor plan with just some mechanical piping and some electrical infrastructure.
And as far as the pump within Forgesville, does that generate a lot of noise?
No, the pump itself that will pump the water out of the ground would be within the well station building, so you wouldn't hear peep.
And is that closest to Route 3? Is that the nearest neighbor?
Yes, I believe so. The fields are closest, and Route 3 is probably closer than any resident. Yeah.
Okay, thank you.
Yes, sir.
I'm Nathan Withington. I'm not a hydrologist, and I'm having a little bit of a difficult time understanding all these maps and the levels, but just using a little bit of common sense, as I understand, this well at Forgesville is going to be, if it's in operation, it's going to be drawing a fair amount of water, which will be taking water from other areas, not only in Forgesville, but around it, which I think was one of those previous charts. So my question really is, if it's drawing from the surrounding area, are there any, in that surrounding or abutting area, are there any brownfield properties which in fact are contaminated properties, both groundwater and underground water, which seems to me would be drawing this contaminated water into this well? And if they're in that area, is there any sort of, or are they in the area, and is there any protection for something like that?
As part of our permitting, we looked at any contaminated sites in the area, and particularly in the Zone 2 area. That's where DEP requires there not be any. And in that area, there are no contaminated sites. There is one to the north and east, but outside the Zone 2. So if we have...
Could you tell me where Zone 2 is?
Yeah, that one right there, the red line. So if you look to the north, there was one contaminated site, but it's outside that red circle. And the red circle says, if I have no recharge, so now I'm getting everything from the aquifer, that shows where the water particles come from, which is different from where you have drawdown. This map tracks the particles that actually make it to the well. And as those particles make it to the well, it does lower the water table. So
On that map, could you tell me where 75 Jordan Road is in relation to that well? Is that in Zone 2? It is?
75, I have to look at the cross section.
I have some bad news for you. I own that property. It's a brownfield property. It's contaminated, and it's been that way for the past 10 years. It still has not met remediation.
Yeah, no, I believe it's outside. I believe we looked at that specific one.
I believe it's 73, 75 Jordan Road. It's, if you can give me a map, it's right opposite Russell Mill Road.
Yeah, I know where you are. We're pretty confident we looked
Yeah,
at it,
yeah.
and it's not inside the Zone 2.
It's not in
Yeah,
zone?
'cause there
Most in
was,
Jordan Road is not.
It abuts Forges Field.
that was
My property abuts
on the
Forges
north
Field.
end, right? That was that a comment that was submitted, a formal comment? Because I took that formal comment and the location of the site, and it was outside our Zone 2. I went to the DEP
I
website
abut
and looked at
Forges
it.
Field, so Zone 2 has to
But the
be.
Forges Field site does extend quite a bit north.
Richard, we could look into it and give you an exact determination. We'll respond
Yeah.
to you, okay?
I'm just worried about,
No, I have looked at that. so
Yeah,
I can get you a map.
it's a contaminated property. It has been for 15 years, and it's been in remediation for probably 10, but it hasn't met remediation yet. And it's a brownfield property, and
Right.
it abuts Forges Field. It's not like in another district. It abuts the property. It used to be the same property as Forges Field, but it was subdivided. So it's not like there's a line or a space between Forges Field and that property.
Right, but as in,
So-
just a point of information, the well's here, the Zone 2, and what the Zone 2 defines, Richard, is that's the area of influence when the well is pumping. So the well is drawing all the water from this area here. So I think your property's up over here.
Right, I
It
believe
is.
it's up
It
there,
is,
so.
yeah.
Correct.
It really draws from upslope, from uphill, so it doesn't draw a lot from the down gradient side. You can tell by the shape, that's where it's getting all the water that's coming towards the well, and not, it has to pull it uphill to get it from down gradient sites. The water table's lower as
I
you go down.
understand water doesn't run uphill, but I
Groundwater
I
flows
would have
down, so
great
the water
concern.
levels are lower.
Okay, but we'll look into it and we'll respond.
Yeah, we are gonna submit formal comments, so.
Hi, everyone. My name is Marlene McCollum. I'm your Assistant Town Manager, and I want to speak a little bit about the Zone 2 in regards to kind of a larger look. We're taking, you may or may not know there are 12 wells in the town, and they all have this zone 2 that is contributing to the water. And we are taking contamination very seriously, and we will be coming to town meeting before your town meeting reps in October to strengthen our zone 2 regulations. We certainly do realize that our land use has an impact on our water quality, and we're very fortunate that we have good water quality and that we don't have to treat our water at a high cost beyond, some pH modification, which is very minimal. So while we're talking about this, I do want you to know that we're taking your water quality, your potable water quality very seriously, and we hope that you also speak to your town meeting reps and support us as we try to strengthen those regulations. Thank you.
Marlene, thank you very much. And again, just to respond further, DEP would have flagged that, but we have the map right here that shows 50 Jordan Road outside of that zone too. Okay? So thank you. Yeah, and 50's further to the north.
I think it's 73, 75.
Those are the closest ones to the zone 2.
Yeah, again, we'll confirm. And as Sheila's pointing out to me, all of Jordan Road is outside of the zone 2. Yes.
I have a question after everyone else speaks, so.
Okay.
Just want to know.
You spoke of a problem with pressure if we extended the line up Jordan Road. From what I can understand, my elevation is pretty much the same elevation as the level until you get further up the street. Is it possible to extend let's say a spur up on Jordan Road so that we could get one more hydrant up there for fire protection? And I'm not sure how far up that would go. It might not get as far as my house, but at least we would have fire protection up there, which we don't have now. If you go way back, this whole area was ravaged with forest fires in the past. It's much more highly developed now, for sure. But if there's not a rapid increase, there's very little increase in elevation in that distance to the next, if you were to add one more hydrant up the road. And it should not be a problem pressure-wise if you're not going uphill. I'm not quite sure how far it goes, but it would certainly, if it goes up further, alleviate some of the people in that, let's say, 53 to 57 area where a drop of water lower, more than is estimated by our estimated models. Something could be done about it, but I'm very uncomfortable with that margin I see there between where the well screens are and where you expect in the long term the water levels to drop. Going up one more 500 feet up the street, or it doesn't have to be necessarily 500 feet till you get to the rise, would not increase pressure on the system because you're not pushing it uphill, but it would give us fire protection. We pay extra insurance on our houses because we do not have water mains there, and at least that would be a help to us, and it might help some people, other people along the way. Thank you.
Yeah, no, I think that's a great idea. I'm happy to look at that and discuss that with environmental partners. And as Ryan mentioned, we'll be meeting with the fire department, and I think the more fire protection we can provide is a great benefit to the community in whole. But we'll definitely look at it, and I will get back to you.
I'm going to have to raise this. So my name is Jim Doyle, 57 Jordan Road. It's kind of scary to see my house number on your map. So first of all, I was a little late. Can I go introductions again? Are you town?
Yes.
Sorry.
Town, Jonathan Peter, Director of Public Works.
Hi, John.
And then Ryan and Anne Marie from Environmental Partners.
And the gentleman.
And Rich Tierney, our Water Superintendent.
Hi, Rich, how are you? So I have a number of things that bother me about this, though. First of all, the process is that the first we and my neighbors heard about this whole thing was a letter I received 2 months ago. All right. It's the first I ever heard of it. And I found that, the town meeting voted on it, so I guess I gotta talk to my town meeting members because they didn't tell us a thing about it. Selectmen voted on it, and there was no notice on their meeting that I saw that was gonna be discussing this. So it just feels like this has all gone on behind us, and now it's happening. It's a real thing. You're gonna build it, and I have a background in science. I understand a lot of what you said. This is all modeled. Your model's wrong. We're in trouble, right? So because we are the people who are the closest to the impacted area, and if your model's wrong, the people on the right side, heading east on Jordan Road, they've got a water main going in front of their houses, right? They can connect. We have nothing. We've got our wells, and if our wells go dry, our properties become valueless, until that is remediated. That's a pretty serious consequence if your model is wrong. Or, I've heard you say, well, you can do 1 million gallons a day. What's the capacity of the pump?
We're limited to only pumping 1 million gallons.
What's the
a day.
capacity of the pump?
About 700 or 800 gallons per minute.
That's it?
Yep.
Okay, so that is 1 million gallons a day,
Yes.
roughly. So, and what would it take you to go to 2 million gallons a day?
We're not allowed to do that. And
What permission would you need?
if we were interested in the future of
Yeah.
trying to get 2 million gallons
Yeah.
per day, we'd have to go through the same exact process with DEP and
Except
updating
the water main would already be there.
Correct.
We'd have to do a pump test, we'd have to do
Correct,
all of that
right.
stuff.
Or 3 million gallons a day, or 6 million gallons a day, right? And again, where's looking out for the neighbors who are the most impacted? I just don't see it. I really feel like this got done in the dark of night as far as we are concerned. So that's our concern. It's all of our concerns. We all are property owners, paid a lot of money for our homes, love it there, and all of a sudden, and no one on this panel will guarantee me we won't be impacted. I'm pretty sure of that. You'll tell me the models say you won't, right? And I know what you do, and I've done the same thing, and and this is a town project. I got it, but my concern is that if you're wrong, you're looking at a few families here. They're going to feel the immediate impact with no recourse. So think about building that stub up to the west side of Jordan Road. Think about building that. I don't know if the pressure test assumes 1 million gallons a day out of Forges in terms of that rise up Jordan Road or not. Ryan, you talked about building an alternative path. We're not talking about building an alternative path. We're just talking about extending the main far enough up so the impacted parties are not impacted. So that's what I ask you to consider. I hope you can. Thank you.
Okay, thank you. Ed?
Hi, Ed Russell, Long Pond Road. I know you've been concerned about future capacity and been concerned about it all over town. And I've been following the Forges Field newspaper articles and what have you for almost a year now. The various sections, or whatever you call the different water districts in Plymouth, this will serve one of them, but is there cross capacity to others? And so when you project need in West Plymouth for this well, how long will that last? When do you see this area, this well, exceeding capacity and thus another well needed? And where will that water come from? And there's a lot of questions. And where else in town are you realistically finding water, and how hard are you working on that?
Yeah, so I think I'll take that, Ed, and I may defer to Ryan for a second, but, Forges is, we're looking at 1 million gallons a day. And, if you go online, Environmental Partners put together a whole report in terms of where we are system-wide and what our needs are. Forges comes online, that really meets where we are in terms of demand today. So we're kind of neutral the second we have Forges online to meet the needs of those other pressure zones. One of your questions was, do we have the ability to interconnect between the pressure zones? Yes. This well will tie into Bradford and Plymouth Center, which gives us flexibility to control water movement between those two and then into other areas of town. So basically, we can fill tanks in those two and then broadcast through the rest of the community. But in essence, bringing Forges online is really addressing the needs today. We are working now vigorously to really increase our ability to provide drinking water. We're trying to do work with Darby. We have a restriction with Darby Pond. We're trying to acquire those water rights by the adjacent bog owners to free up the restriction there. What happens in the summertime during the drier periods, the pond level dries up and the cranberry growers have first rights to that water. So our permit really reduces our withdrawal amount. So that has an effect directly in West Plymouth and Plymouth Center because that's directly adjacent to those areas. As I mentioned, we got funding for a water master plan. Within that water master plan itself, we're going to be looking at, we mentioned those 21 well sites back in the 2006 master plan, brought down to 5. We'll be relooking at all of those sites again to really prioritize where the next well will be located. I hope that answers the question. Yeah. Yes, sir.
How you doing? 428 Long Pond. I'm a Form A lot from Forges, which was old Voltop property back then. When you did the test, were both golf courses on? Waverly and Crosswinds?
Yes, they were.
Were at capacity at the time?
We did it in July, so we actually, during the test, both wells had been pumping. During the test, we did not have the Forges Field irrigation well on because that would interfere with our being able to get a good drawdown curve in the distal wells. You'd have interference. So we wanted to understand what the aquifer was doing, so that's what we would put in the model.
Mm-hmm.
And also, we were lucky in that the well wasn't working at that time, so we couldn't have had it on.
I mean, that's quite a draw, obviously. If you're not adding any more water to what you're already saying you have pumped previously, where did we lose that water from?
So when we talk about redundancy, as a planning tool that's set forth by American Water Works Association and what generally used for engineering good practice is what happens when you're trying to meet the max day demands, which are typically in the summertime when people are vacationing or kids are home and you're using outdoor water, your demands skyrocket. They're about twice as what you normally use during the day. So we have to always look at the capacity of the wells to meet the demands in the summertime to make sure that we can meet the demands year-round, not just in the winter or the summer. So as a planning mechanism, we always want to make sure the well supplies can meet those max day demands with the largest well offline, meaning if there was a mechanical failure at one well, could you still meet all the max day demands? So whenever we talk about a deficit, it's the deficit with the largest source offline. And 2016, that was experienced. I think you may, and I didn't live through it, but I know Rich and JB did, Sheila, Peter as well. They had multiple sources offline, record demands, and they had to go into the emergency water declaration. So
Yep.
it does happen. So if people think it's too conservative, it is the planning mechanism that is accepted and adopted, and that's what we usually generally go by.
May not be relevant here, but did they close the Clark Road well site? Is that shut down?
We put the 200-acre site on hold for now.
For what reason, JB?
There's a lot of permitting and there's a conservation restriction on that, and we felt it'd be better to really, pursue Forges Field first and stop moving forward with the water master plan and then discuss 200-acre at that time.
So no hydrants down Long Pond or anything?
No, we are
through
not
this
doing anything
project,
related
just
to the 200-acre well.
Tapping
at this
our
time.
aquifer.
Correct.
I mean, I have to pull up my point this year for the first time in 25 years, and I'm 318 down, so. I mean, it could be a bigger impact than projected, that's all. Thank you.
Thank you. Other questions?
Thank you, Mr. Doyle. My name's Laurie Aninos. I live on Russell Mills Road. And I have some questions. You said that extending this water line would serve the Bradford well? Would connect to the Bradford well?
The Bradford zone.
The Bradford zone.
Correct,
Does the Bradford zone include West Plymouth, the area you're supposed to be helping?
No, West Plymouth has its own pressure zone, so
Well,
we have the West Plymouth zone, the Bradford zone, and the Plymouth Center zone, which are the northern zones for the town, and we're providing this water, and the Bradford zone can generally send water down to Plymouth Center, and Plymouth Center generally pumps water into the West Plymouth area. And it's a little confusing.
Because all I heard was going to the Bradford zone, and then West Plymouth isn't in the Bradford zone, so.
Right, yeah. And I think another gentleman asked that question as well.
Yeah.
The three northern zones are generally interconnected, and water can be called wheeled or pumped or sent down to a couple of different pressure zones or wherever water is needed. If there's a fire in one zone, we could turn a pump on and send it to the area where water is needed. But generally, there's if one of the zones has less supplies of water, then we need to bring water into that zone to meet the demands of that zone. Okay.
Thank you. May I ask Nathan Withington a question? What, you said that the sites you were talking about were contaminated 15 years ago, and it's near Russell Mills Road. What is the contaminant in that area? How did contamination get in there? And do you know about it?
I do.
Excuse me? What? A heavy metal. Really? Was that just a dumping zone where people just dump things? Or? By whom? Oh, yeah, okay.
It's from the old Boston woven hose, which was about
Well, that's what, okay. Yeah, but you said 15, and yeah, the mills at Russell Mills, Boston woven hose, contaminated next to the Eel River, which one of the Withingtons mentioned years ago at town meeting. So I was just wondering, well, you're talking about 75 Jordan Road, but it's something, so, okay.
It's not on, the frontage is on Jordan Road. The property is about 10 or 11 acres.
Wow.
If you go back to the map,
Mhm.
approximately, it looks like it's, I guess I don't want to confuse the issue, but it's right near where the well is.
Yeah, I understand that. You mentioned that it abuts the well zone, but now you've connected it to Boston woven hose, and it's just for historical comments. That's amazing. That nothing's been done about it. It's a brownfield.
Correct.
How is it ever going to be correct? And this isn't. I know it's not germane to this, but I'll drop it at that. But how is it? Who's going to decontaminate it, and when? It's been 100 years. Yeah, really. Oh, okay.
That's the easiest way to describe it.
Okay. It's the first I've heard.
Excavated, taken to
Okay. Okay. Thank you.
upstate New York,
Thank
Yeah.
you.
Yankee Stadium.
Yeah. Sure.
And just to help you describe where the Zone 2 goes, it goes up to the power line easement, just to the north of the production well. So it doesn't go beyond that power line easement.
Map up, I can show you where it is, but it's all academic.
Yeah.
Okay. Sorry to belabor this.
No, I think think it's important.
I believe the property is right there,
If you look,
if I'm not
Yeah.
mistaken.
Okay, thank you.
It's antimony, lead, and zinc.
Isn't that wonderful?
Yeah.
Yeah, great. Good old Boston Woven Homes. I had another question. You mentioned that the difference in footage from running this down Jordan and up Russell Mills Road versus going down Long Pond Road was something like 2,000 feet, and construction would be $200 a foot. And I'm remembering what my brother Daniel Enos said at another meeting prior to this, where he suggested running the water line, running this down Long Pond Road so that people could connect to the water line and bring revenue to the town with their water bills. So you're saying that's 2,000 feet difference for a project, well, and $200 a foot. That's only less than $500,000. That's less than $500,000, and you can recoup that in pretty fast time, possibly. And I have a question about, you said there's some contamination, ma'am, you said it, I guess, in the northeast area. So you said north of here. Were you referring to the same one that Mr. Withington was referring to? Okay. But again, I can still repeat that I'm not sure, but right next to the Eel River, where the old mill used to be, right next to the Eel River on Russell Mills Road, that used to, I think that used to have scrap rubber in it or something like that. That's what I learned years ago. Okay.
so the
that-
Zone 2 doesn't go anywhere near
Yeah,
the
mhm.
Russell Mill.
Well, now I'm thinking about Russell Mills Road, okay, because that's where I live. Okay, let me just think of, and you said it was 3.5 miles. And I was wondering, you mentioned the High Lines. As you didn't mention it, but I'm thinking the High Lines are in there. Can you show me with your little flashlight where the High Line is there, next to, related to the Forges Field well? It's
You mean
going
the-
towards Long Pond
You
Road.
mean the power lines?
Yeah, the power lines.
Oh.
Where, could you show me approximately where that is on the map there?
Just go to the map.
Can't see it, I guess.
Oh, further
Okay.
up.
Yeah, go to the satellite map. There you go.
Right there?
Like,
That cleared area is the power lines.
oh, okay, I was just thinking, it would be pretty easy to run a ditch right down the power lines.
And that's Route 3.
You probably can't do that, right?
No.
I didn't think so.
It would be
Okay.
nice.
Okay, I have one, I guess I have one last comment, which really concerns me. I was checking with a local expert, well, at the last meeting, the public meeting, that not so many people heard about, talking about the actual construction along Russell Mills Road, because that's where the Eel River is, okay? The Russell Mills Pond, and then it flows over the dam into the Eel River. And in that area, the construction is something that, and I'm not an engineer, but I've never heard of it. They plan, right now, the existing construction of every water line that I've ever heard about, going, under a bridge or something like that, the pipes are just attached to the bridge and things. But in this case, someone proposes a construction of tunneling under the Eel River and back up again. Okay, seems to me as though it would be a heck of a lot simpler, and it's been done for, since the beginning of time. Why did you change the design? Is that so somebody else can make a whole lot of money doing that?
No, this is actually the least impact to the environmental resource area and less costly than actually trying to hang a pipe that's insulated over a bridge or this type of work now is done all the time.
You can, but you can just because it's insulated, you can still put another coat around that. I guess. I mean, I don't understand that whole thing, and I know maybe you're not prepared to show us that, but it seems to me as though, isn't that rather expensive? How do I find out what the cost of that is versus just running the pipe, for 20 feet across the Eel River?
That's more of a question for the Conservation Commission. I think
Well,
they would much at the meeting. I think they were all on the same page as we with the drill pits stayed as far away from the river as we could. So we're almost outside the buffer zone in the riverfront area. The cost to directionally drill is Probably just for the,
Oh, what's that called? Again, will you show me
it's
what's
called horizontal directional drilling.
horizontal directional drill? Thanks.
Right, and it's probably about $50 per foot more expensive to do that kind of work than it would be to normal
Really?
trenching it.
Really?
Right.
Well, I'm not saying, no, this wouldn't be trenching. This would be having a pipe that's suspended the way it is now under the bridge. And that's, I mean, there's no other place in town that I know of that has any kind of construction like that.
Just a good point of information. The technology has changed tremendously in terms of, you know, tunneling, directional drilling over the past 5 years, 10 years. There's no better way than this to do this.
Really?
In terms
Where
of
can I see that?
constructability.
Where can we see that?
You can Google it. I can get you information on it.
Okay.
Everybody's doing it. It's one of those
Oh,
things.
not in
Instead of
Plymouth.
disrupting the environment, less impact on the roadway, a lot quicker in terms of sustainability. It meets every
Really?
criteria we would like to see
Really?
in terms
Less
of
impact on the
construction.
roadway as well.
Absolutely.
Really? That's interesting because here's my other thought. Russell Mills Road is a dead end. If anything happens in that construction, whereas I'm thinking, you know, okay, you got the pipeline, you run the pipe under the bridge, you hook it up, that's it, okay, easy. But if something happens in that drilling operation or anything around that bridge in the Eel River, number one, you're going to contaminate the Eel River. Number two is that if anything happens upland from that, where that possible accident happens, nobody gets out. You know, what happens if somebody has a heart attack? No ambulance can get in there. If we have a fire, no fire truck can get in there. So somehow I would like to be assured that there's some guarantee that you can cross that river whenever you need to.
Absolutely, and I believe we spoke about that months ago. I spoke to a couple of residents on access because not so much at the brook crossing, but further up, Russell Mills does get narrow.
Yeah.
So in working with a contractor, they have to keep access because the fire department and, you know, public safety is going to want to get access down there. And as Ryan mentioned, the contractor will be well aware of that, and they have to provide uninterrupted access, especially during school season, you know, when school's in session for any buses that have to
Yeah,
go
well,
down.
I'm just thinking about
So that will
possible
be done.
emergencies, not everyday life.
Understood.
Yeah.
But we look at both.
Okay. Okay. Thank you very much.
I do want to answer your question about Long Pond Road. You know, as far as.
Oh, yeah,
as that,
right,
you
yeah,
know,
is
again, this project is for redundancy.
Yeah.
And the reason why we can't do Long Pond Road, it wasn't all based on economics, it was based on hydraulics. In terms of meeting those pressures, we couldn't do that with as well as in tying into those pressure zones that way. And that's why we didn't go the Long Pond Road.
Yeah, the only other thing, I know, I mentioned, I think one of these residents was talking about another hydrant on Jordan Road.
We've already addressed that.
Well, my comment is I drive down Jordan Road all the time, and next to Kingfisher Lane is a hydrant, but it has a sign on it that says it's out of service.
Correct.
So I just want,
This project will put hydrants back in service. Yeah.
really? Okay.
Yes.
I thank you very much.
Thank you.
Hi, everyone. Neighbors, I'm Dawn Fenari. I live at 81 Jordan.
Yeah, microphone, please.
I live at 81 Jordan. New to all of this, when we moved down here about 10 years ago, Pine Hills was really the premier, growth stages, and we were getting notices in the mail about, oh, come to town hall because they're going to be draining water from your wells. So back then I was a little concerned. Now I'm even more concerned, and I was hoping, I see the positives. I love to have a fire hydrant in my neighborhood and all that. But I'm just wondering, you said that, this will help with any future increased needs for residential or commercial. So I just wonder how this relates to like the Exit 5 development that's going on and Pine Hills. I don't even know if it is connected, but if we're gonna be taking water from where I live to go supply other people at the expense of my well and my neighbor's wells, I'm a little concerned. And obviously the construction. My second question, if you can comment on that first, but my second question is there gonna be a cost? I don't even know if I qualify for this connection because I'm right at the entrance of Forges Field. And you're going right, but I'm on the left, so I don't even know. Is there a cost to the neighbors to have that put in? So those
Okay.
are my concerns, like how much development are we really trying to do at our expense?
Understood. So you asked a couple of questions. The first one was, you know, Pine Hills Exit 5 development. You know, Pine Hills has its own water system, and nothing to do with the town, unrelated. You know, same aquifer, but again, you know, through our modeling, the Pine Hills well was included in this model. So, you know, all pumps, all wells running at the same time, okay? For those of you who may not be aware, we run the water budget, what's called the Water Enterprise Fund, okay? That's self-sufficient. That is not, you know, sustained by the general fund. So all the ratepayers cover all your costs in terms of projects like this, okay? So you are not gonna get a betterment or anything for this construction. If you are on town water right now, these costs are being borne by those ratepayers. Exit 5, you know, the work there, what we do is anytime there's a large-scale commercial project, we use environmental partners to run a model to see what the impact is on those peak demands to make sure that our system can handle it. And if not, they're responsible to do mitigation to make sure that the system can handle it. Okay, so we do that on a case-by-case basis, you know, in all the different pressure zones. As far as a connection for you, this project, anywhere that the main goes in front of a property, will run a service over to the property line with that curb box. It's gonna be the homeowner's cost. It's gonna have to be borne by the homeowner to connect, make that new connection, if you have an existing connection, from that curb box to your meter, okay? So that's gonna be the responsibility of the homeowner with this project. So we're all, the water main, the new water main that goes down Jordan and Russell Mills Road, we will, as part of this project, run that service to your property line. But if you're directly adjacent to that corner, I'd have to look at the plan and see if we could put a service for you. I'm not sure about that. I'd have to look into that for you, okay?
The plans are up over here. I can review them if you like.
So I want to talk a little bit about your question about growth. The Board of Selectmen serve as your water commissioners, and they are tasked with making sure that people, companies, anyone who wants to move into town can be provided with the proper infrastructure. So we're a growing town, we're a big town, and we're a growing town, and it's our responsibility to kind of plan for the reality that we're all going to be facing. And we are going to be experiencing it, we are experiencing currently economic development, and generally that's a good thing. We like the commercial growth, we like the commercial taxes. We might disagree on where it goes, and we might disagree on the details. Town meeting has zoned certain areas for industrial and commercial development. We are trying to provide adequate services for those areas. We're also trying to provide adequate services for our residents. And we're planning, hopefully we're planning in a way that does as little harm as possible. But it's certainly not good for us as a community to find ourselves in a situation where we don't have any more water to sell, and we don't have any more, or we don't have the water we need for a major fire, if that's the case. So we are talking about economic development. We are talking about additional growth. We are also talking about responsibly managing the people and the businesses we already have. And we are at the point where 2016, if we had a major fire and if it was August or September and we were in a severe drought, it would have been very difficult for us to provide you, if you're on the water system, it would have been very difficult for us to provide you with enough water. So I know that it feels like we're taking water from you and sending it to other parts of town, and that probably feels a little unfair. That's the way the system works. The water is routed where it's needed at any given point in time. And eventually, if we're doing a good job and if we're planning well and if we're operating our system well, nobody is shorted. We have enough water to supply everybody in the proper way. And that's what we're trying to do by bringing more wells online and by the water system, or the water master plan. So I do understand that it feels like we're taking something from your neighborhood and giving it to West Plymouth. We're all one town, and we want to grow sustainably and responsibly, and we want to use our resources sustainably and responsibly.
Any more questions? Okay.
I just want to respond to that. So, yeah, you're right. So the town needs the water, right? I got that. But no one else is threatened by the water they're getting, and the water that's moving, except the abutters. And we pay taxes. We pay a lot of taxes. We have no access to town water, and you're not giving us any. So we're not trying to get in the way, but give us an option. Give us something that says, and I'll pretty much guarantee the 2006 Plymouth Water Plan didn't project this, right? The model didn't say we'd be out of water again, right? Now we're out of water again. So I trust models to a degree, because the conditions around models change. Growth happens, or it wasn't going to happen faster than it was going to happen. All of a sudden, you're short again, right? And we are the ones, again, we're the ones threatened by it. We pay a lot of money in taxes also. All we want is an option. Give us the same option the rest of Jordan Road gets. That's all. Thanks.
Okay. Well, again, I appreciate everybody's, do you have a question? Okay, we really appreciate everybody's time. I think it was a good discussion. We learned a lot. We'll stick around if anybody has questions. The plans are out the back. Again, please, if you'd like, give us your name and address and email address so we can send you information or updates. I have some cards here. If anybody would like to follow up with me, I'm happy to discuss this further, sit down with you, or discuss any questions. So again, thank you very much. Have a great night.